Hello student, welcome you going well. This is my channel Olampiadia, one of the best channel for mathematical Olympiad. And this is the section of all context bring in Olympiad. Today we are going to solve an equation in integer dominant. So we have a pairs of number in integer x and y, and those number make a equation that is y to the power of 4 is equal to x dot 2x to the power of 2 plus y, all of them to the power of 3. So by the property like number theory and divisor and GCD, we can solve these problems. So let's go through the question. Find all integer pairs of x and y numbers that satisfy in this equation. As I said, this equation is y to the power of 4 is equal to two parameters. Like the first parameter is 2x to the power of 2 plus y to the power of 3, and the second is x. And these two parameters is multiplied together. When we multiply two integer number, we know that one of the number can be a divisor of the result number. So we can use this property in solving these questions. Okay, we can go through the question. First, we rewrite the question. Y to the power of 4 is equal to x dot 2x to the power of 2 plus y, all of them to the power of 3. So we have a fourth power, a 1th power, and a third power. So these lead us to use the GCD of x and y. So let's suppose D is equal to GCD of x and y. And GCD means greatest common divisor of x and y. So x is equal to AD and y is equal to BD. And A and B are prime together. So we can rewrite the original equation. Y to the power of 4 is equal to BD to the power of 4. X would be AD and Y to the right equation would be BD. So AD dot 2 AD to the power of 2 plus BD, all of them to the power of 3. We can pull out all of the sub factor like B and D and A. So BD to the power of 4 is equal to B to the power of 4 and D to the power of 4 and multiply together. And AD to the power of 2 is equal to A to the power of 2 dot D to the power of 2. So the equation converts into B to the power of 4 dot D to the power of 4 is equal to AD dot 2A squared D squared plus BD, all of them cubed. So we can simplify D factor from the both section. D to the power of 4 and D to the power of 3 from the right section. So AD can be simplified by B to the power of 4 and D to the power of 4. And we know that D can simplify from the both sides, and we lead to B to the power of 4 D cubed is equal to A dot 2A to the power of 2 D squared plus BD cubed. And by getting D cubed to the right section, we have B to the power of 4 is equal to A dot 2A squared D squared plus BD cubed, all of them divided by D cubed. And D cubed can enter to the parentheses. And by entering, the power of D can be 1 because the whole power is 3. And we lead to this expression. B to the power of 4 is equal to A dot a big parenthesis, and inside the big parenthesis we have 2a squared d squared plus bd over d. And the big squared is to the power of 3. By simplifying the expression, we have this expression is equal to a dot 2a squared d plus b, and all of them to the power of 3. Now we have b to the power of 4 is equal to a dot 2a squared d plus b to the power of 3. And we know that a multiplied by an integer number. So a is a divisor of b to the power of 4, or b to the power of 4 is divisible by a. But we know that a and b are prime together. So we lead that a is equal to 1 or minus 1. And we pay into the positive number as a is equal to 1. If I assume that a is equal to 1, the equation changing to b to the power of 4 is equal to 2d plus b cubed. And we know that b to the power of 4 is a fourth power of a number. And the right of the equation we have cubed of a number. So those of number are a number which is the power of 12 of another number. So we can assume that this number is equal to t to the power of 12. And t to the power of 12 is equal to b to the power of 4. So b is equal to t to the power of 3, because we can now get the fourth root of both sections and lead to this equation. B is equal to t to the power of 3. And we know that t to the power of 12 is equal to 2d plus b, all of them cubed. So we can lead to t to the power of 4 is equal to 2d plus b. And we already know that b is equal to t to the power of 3. So t to the power of 4 is equal to 2d plus t to the power of 3. And we can get the d parameter from here. The d parameter can be get from t parameter. So d is equal to t to the power of 4 minus t to the power of 3 divided by 2. We can assume t as arbitrary number here, but t should be an integer number. So d is equal to t to the power of 4 minus t to the power of 3 divided by 2. And this is the parameter solving of this equation. By having d, we can have x parameter, because x equal to a dot d, and a already would be 1. So x is equal to ad, or d is equal to t to the power of 4 minus t to the power of 3 divided by 2. And by having this, we can obtain the y parameter. Y parameter is equal to b dot d, and b was t to the power of 3. So bd is equal to t to the power of 3 dot t to the power of 4 minus t to the power of 3 divided by 2. And this is equal to t to the power of 7 minus t to the power of 6 divided by 2. So x and y now completely solved, and we can get this parameter as t. And t is an arbitrary number. So we can collect all of this information into these parentheses. X and y pairs is equal to t to the power of 3 minus t to the power of 4 divided by 2, and t to the power of 6 minus t to the power of 7 divided by 2. And t can be a member of integer number. So we can solve the question completely. Okay, I have finished this video here. I hope you all enjoyed this video, and until the next video, have fun and goodbye.